Hi. Imagine someone is designing a wind turbine and you are asked to help to design the power conversion system for it. So what will be there between the blades and the grid? Would it be a gearbox, a generator, a frequency converter and a transformer? Or can we skip some of the components? And a new round of questions. Imagine the design requirements are the lowest possible weight and the highest possible efficiency. So what kind of a gearbox would you use? What kind of frequency converter would be the best for your turbine? Good task for both a wind turbine designer and for an electrical engineer, isn't it? Imagine now you have a pump and you know all the parameters of the pump, what volume of water and how high it is going to lift. You also know the electric grid you can use to power the pump is 400 volts. What system would you need between the pump and the grid to drive and control the pump efficiently? How to design the system so that it has lowest possible cost? DriveConstructor will teach how you come up with your own design. The goal of the course is then really to convey a distant perspective about how we engineer systems. Let's look inside. That's the course web page. You start with selecting the application and choosing the topology. The next step is defining the application parameters. For example, if our application is a conveyor, then we need to set up torque, speed, overloads and so on. Then the software usually immediately offers a system design, since it has all the component parameters preset to some default values. So everything you do now, you play with the component parameters and make choices the system offers you. When you make the choice, you can check the chart with the curves, the load curve and the system curve. If we take any three experienced engineers in the area of power conversion and depict their knowledge and skill sets as the circles, then we'll probably see that some of their knowledge is unique, but at the same time there is a big overlap, and this is the knowledge and skill any good engineer needs to have. And this common knowledge is what DriveConstructor can give, and this is what will make you competitive on the job market as the specialist. But please note that knowledge is not only being aware of the facts, it is also understanding the interconnection between the facts and having the facts and the interconnections and dependencies systematized. It is like seeing the full picture. DriveConstructor can help you both learning about the facts and the principles. It will also help building the practical skills. How would you actually depict knowledge? Could it be like that? Or something more structured? I would choose another variant. It is like a puzzle consisting of multiple interconnected pieces. That is how we see the knowledge and skill pieces hidden in DriveConstructor. The pieces can be put in place by working with the exercises. So, self-education process is built around the exercises. How you choose your exercises may depend on your area of study. If you are studying civil engineering, probably you will tend to work with pumps and conveyors. In marine engineering, one cannot go around winches and cranes. Electrical engineers will probably benefit from all the exercises. Anyway, the question of selecting the right exercises is dealt with in detail in a separate video. To conclude, developers of DriveConstructor project declare its mission as faster knowledge acquisition. It means learning faster than in the conventional educational process at university. And here, your capability to acquire new skills can become your competitive advantage. DriveConstructor is the machine for knowledge acquisition. Start it up. Thank you for watching and good luck.